In today's class, we are going to begin with solution of quadratic equation by completing the square. Okay. We'll understand this method by a question itself, and why are we doing this method of completing the square is because by this method we'll learn how to find out the quadratic formula. So first question, find the roots of the equation. Five x square minus 6x minus 2 equals to 0 by the method of completing squares. So, solution. First of all, what we do is, so given to us is that 5x square minus 6x minus 2 equals to 0. So our first step is to make the coefficient of x as 1. So this implies we'll take 5 common. X square minus 6 by 5x minus 2 by 5 equals to 0. Why does this 5 come in the denominator? Because this 2 had no 5 in it. So when we take 5 common, we need to divide by 5 because 5 into 6 by 5 will become 6. That is why when there is no number and we take common that number, we divide by that particular number. So this implies x square minus. Now we'll bring this in the form of a square minus 2ab plus b square. So a square x square minus 2, a is x. Now what are we left with? 6 by 5. If we take 2 outside, what we are left with is 3 by 5. So a square minus 2ab plus we need b square. So we added 3 by 5 whole square on our own. So we also need to subtract 3 by 5 whole square. And we had minus 2 by 5, that is equals to 0. 5 goes to the other side. 0 by 5 is basically 0. Now this portion is basically x minus 3 by 5 whole square minus 9 by 5 minus 9 by 25 minus 2 by 5 equals to 0, which implies x minus 3 by 5 whole square equals to 9 by 25 plus 2 by 5, which implies x minus 3 by 5 whole square equals to this LCM 25, this is 9, 5 5s are 5 2s are, so 10 plus 9, 19 by 25. So this implies when square changes side, we get a plus and a minus. So minus 3 by 5 equals to plus minus root under of 19 by 25. So whenever square changes side, we get a plus minus and a square root. So this implies x equals to 3 by 5 plus minus root 19 by root 25 is 5. This equals to 3 plus minus root 19 by 5. Plus minus means there is plus also for one solution and there is minus for the other solution. So therefore the roots of the equation five x square minus 6x plus 2 equals to 0 are 3 plus root 19 by 5 and 3 minus root 19 by 5. So this will be the two roots by the use of completing squares. Okay. So the next example, find the roots of 4x square plus 3x plus 5 equals to 0 by the method of completing squares. Solution. So given 4x square plus 3x plus 5 equals to 0. So this implies first we'll make the coefficient of x square as 1. So x square plus 3 by 4x plus 5 by 4 equals to 0. So a square plus 2ab. See, the 2 we took common from the numerator, but the numerator did not have 2 in it. So what we'll do, if we are multiplying by 2, we also need to divide by 2. So 3 by 8 this will turn into, because 2 into 3 by 8 is 3 by 4. Plus, as we have 3 by 8, so we'll take 3 by 8 whole square, and we'll also subtract 3 by 8 whole square, and we have plus 5 by 4 remaining equals to 0. So this implies this 3 together forms x plus 3 by 8 whole square minus 9 by 64 plus 5 by 4 equals to 0, which implies x plus 3 by 8 whole square equals to 9 by 64 minus 5 by 4. So LCM is 64. We have 9 minus 4 into 16. 16 5s are 80. So this implies x plus 3 by 8 whole square equals to minus 71 by 64. Now this is a problem because the square of any real number should be positive and this is less than 0. So which is not possible. So hence we conclude that there is no real value of x satisfying the given equation. Or we can also say over here that the given equation has no real roots. Okay, now we will see how to convert quadratic equation, any standard quadratic equation, into your finding the roots using this completing squares. So the quadratic formula. This is also called Sridhar Acharya formula because Sridhar Acharya was the one who formulated this. So a standard quadratic equation looks like ax square plus bx plus c equals to 0, where a should not be equals to 0. So then it becomes a quadratic equation. So just like we did in completing squares, first step what we do is we make quotient of x square as 1. So we take a common, we have x square plus b by ax plus c by a equals to 0. This implies x square plus b by ax plus c by a equals to 0. Now we will convert this in terms of perfect square. So a square plus 2a is x into b. Since we multiplied by 2, we also need to divide by 2. So 2 into b by 2a, 2 cancels off, b by a x. So basically we are getting back the same thing. Plus, since we have b by 2a, so as b, so a square plus 2ab plus we need b square, so b by 2a whole square. We are adding this, so we also need to subtract this, plus c by a equals to 0. So this implies x plus b by a 2a whole square equals to b square by 4a square minus c by a, which implies x plus b by 2a whole square equals to b square. See, the LCM over here is 4a square, so a into 4a, so minus 4ac, which implies x plus b by 2a equals to plus minus square root of b square minus 4ac by 4a square. This implies x equals to minus b by 2a plus minus root under of b square minus 4ac, and square root of 4a square is 2a. So this implies x equals to minus b plus minus root under of b square minus 4ac whole divided by 2a. So this is our quadratic formula. Now this comes by the method of completing square. So what we can do is we can directly put the values in this itself of a, b and c, and we can formulate the result. So let's look at some questions and solving them using quadratic formula. Okay, we'll solve some word problems right now, but in the last lecture we'll be focusing mainly in the word problems itself. So in this lecture we'll learn some word problems, but those are not the ultimate ones. We'll learn them properly in the last lecture. Find two consecutive odd positive integers sum of whose squares is 290. So two consecutive odd positive integers. So let say 5 if we consider. So 5 is one odd positive integer. Then the next consecutive odd integer is 5 plus 2, that is 7. So if we take x as one of the odd positive integer, then the next odd positive integer will be x plus 2. Solution: let the smaller of the two consecutive odd positive integers be x. So therefore the second integer will be x plus 2 according to quotient, the sum of whose squares is 290. So x square plus x plus 2 whole square equals 290, which implies x square plus 4x plus 4 plus 290 comes this side, minus 290 equals to 0, which implies 2x square plus 4x minus 286 equals to 0. 2 comes common from all of them. X square plus 2x minus 143 equals to 0, which implies x square plus 2x minus 143 equals to 0. So what we can do next is comparing. Either we can compare with the standard form, or we can write that this is of the form ax square plus bx plus c equals to 0, where a equals to 1, b equals to 2 and c equals to minus 143. So using the quadratic formula, we get x equals to minus b plus minus root under of b square. So 2 square is 4 minus 4 into a into c. So 4a, c is minus 143 whole divided by 2 into a. So minus 2 plus minus root under of 4, minus into minus is plus, 143 into 4. Or what we can do is, from this 2, 4 comes common. Here we are left with 1 plus we have 143. This will be a much easier method to calculate, by 2, which is equals to minus 2 plus minus 4 comes out of the root, becomes 2. We have root under of 144 by 2. So now 2 comes common, minus 1 plus minus root under 144 is 12 by 2. This 2 cancels off. We have minus 1 plus minus 12. So this implies x equals to 12 minus 1, that is 11, or x equals to minus 1 minus 12, that is minus 13. But x is given to be odd positive integer, therefore x is not equals to minus 13 and x will be equals to 11. Thus the two consecutive or positive integers are 11 and 13. So this is our solution. Next example. A rectangular park is to be designed whose breadth is 3 meter less than length. Its area is to be 4 square meters more than the area of park that has been a shape of an isosceles triangle with its base as the breadth of the rectangular park and of altitude 12 meter. Find its length and breadth. Okay, So in this question, we need to understand what is given first. So there is a rectangular park, so which is to be designed, whose breadth is 3 meter less than its length. Its area is 4 square meters more than the area of park that has been a shape of a isosceles triangle with its base on the breadth of the rectangular park. So let's make the diagram. So first of all, we have, say we are making length over here and the breadth over here. Why are we making like this? Is because the breadth, this base of the triangle is on the breadth of this rectangular part. So it looks better in this way. So it's given that the breadth is 3 meter less than the length. So solution, let the length of rectangular park be x meters. So therefore length L equals to x meters. So therefore breadth B will be equals to 3 less than the length. So x minus 3 meters. Now its area is to be 4 meters more than the area of the park that has been a shape of an isosceles triangle, okay, and whose altitude was 12 meters. So this altitude perpendicular is 12 meters. The length is x and the breadth is x minus 3 meters. So according to question, what is given to us is that the area is to be 4 square meters more than the area of the park. This park is isosceles park. So area of rectangle is supposed to be 4 units more than the area of triangle. So this implies area of rectangle will be length into breadth, that is x into x minus 3. Area of triangle will be half into base into height plus 4. So 2 ones are to 6 are. We have x square minus 3x equals to 6x minus 18 plus 4, which implies x square minus 3x minus 6x plus 18 minus 4 equals to 0, which implies x square minus 9x plus 14 equals to 0. So now we need to get 40. So since here we can middle term break over here, 7 plus 2 is 9 and 7 into 2 is 14. So we can do this by middle term breaking, but let's try this out by the quadratic formula. So or say we'll try by both the methods. So this is first method, where we are doing middle term breaking. X square minus 9 as 7 plus 2 into x plus 14 equals to 0, which implies x square minus 7x minus 2x plus 14 equals to 0, which implies x minus 7 minus 2 x minus 7 equals to 0. This implies x minus 7 x minus 2 equals to 0. So which implies either x minus 7 equals to 0 or x minus 2 equals to 0, which implies either let x equals to 7 or x equals to 2. Now over here, so if length is 7 meters, then breadth is x minus 3, that is 7 minus 3, 4 meters, and if length is 2 meters, then breadth is -1 meter. 3 minus 2 minus 3 is -1 meters, which is not possible. So therefore length is equals to 7 meter and breadth equals to 4 meter. Now let's look this by the quadratic formula. So while writing quadratic formula, so this is of the form ax square plus bx plus c, where a is 1, b is -9 and c is 14. So therefore, using quadratic formula, we get x equals to -b plus minus root under of b square, -9 square is 81, minus 4ac by 2 into a. So this is equals to 9 plus minus root under of 81 minus 14 into 4 is 56 by 2, which is equals to 9 plus minus, this becomes root under of 25 by 2, which implies 9 plus minus 5 by 2, so which implies x equals to, if we take plus, then 9 plus 5 is 14 by 2, 7, or if we take minus, then 9 minus 5 is 4, 4 by 2 is 2. So either x will be equals to 7 or x will be equals to 2, just like the previous case. When x equals to 7 meters, x minus 3 equals to 4 meters, and when x equals to 2 meters, x minus 3 equals to -1 meter. This is not possible. Therefore, length is 7 meter and breadth is 4 meters. So this is how we solve this type of problem, and this is how we can use either quadratic or middle term breaking as well. If it's possible to middle term break, go for middle term breaking, it will be shorter. And if you are confused with middle term breaking, you can also use quadratic formula. This is also perfectly fine. Okay, next example. So find the roots of the following quadratic equation. If they exist using quadratic formula. Okay, so in the solution, part 1, we have 3x square minus 5x plus 2 equals to 0. Now why in the question have they mentioned if they exist is because, like while we were doing completing squares in this case, here we got, over here while we were solving this, we got a square of something as negative. This was not possible, so here roots did not exist. So while checking if roots exist or not, so root under of this number, so this number should be greater than or equals to 0. So root under of negative number is not defined at all. So that is why we depend upon b square minus 4ac to check if the roots will be real or not. So roots will exist if and only if b square minus 4ac will be greater than or equal to 0. So solution, this is of the form ax square plus bx plus c equals to 0, where a equals to 3, b equals to minus 5, c equals to 2. So we'll check b square minus 4ac, so that is b square minus 5 square minus 4ac equals to 25 minus 4 3 12 12 to 24, that is 1. So b square minus 4ac, this is greater than 0, therefore x equals to minus b plus minus root under of b square minus 4ac, that is 1 by 2 into a, which is equals to 5 plus minus 1 by 6, which implies if we take positive, then 6 by 6 we get 1, or if we get negative, so 5 minus 1, 4 by 6, that will be 2 by 3. So either x is 1 or it is 2 by 3. Hence the roots are 1 and 2 by 3. The second part, 2x cube minus 2 root 2x plus 1 equals to 0. Solution, we'll proceed in the same way. This is of the form ax square plus bx plus c equals to 0, where a is 2, b is minus 2 root 2 and c is 1. So b square minus 4ac equals to minus 2 root 2 whole square minus 4ac. So this is 4 into 2 minus 4 into 2. 4 into 2 minus 4 into 2 is basically 0. 8 minus 8, that will become 0. So therefore x will be equals to minus b plus minus root under of b square minus 4ac by 2 into a. So this implies x equals to 2 root 2 by 4, 2 ones are 2 twos are, so root 2 by 2 is basically root 2 into root 2. So this cancel off, we have x equals to 1 by root 2. Now plus or minus 0 will get the same thing, that is 1 by root 2. So the roots are 1 by root 2 comma 1 by root 2. We say that the roots are equal in this case. There will be two roots and the roots are equal. A quadratic equation has degree 2. So degree 2 will always have two roots. This is called real and distinct. Two separate, both are real, and there are two separate, real and distinct. This one, both are real and they are equal. So real and equal. And the third question is x square plus 4x plus 5 equals to 0. So this is of the form ax square plus bx plus c equals to 0, where a equals to 1, b equals to 4, c equals to 5. Therefore b square minus 4ac equals to 4 square minus 4 into a into c. So 16 minus 20, that is minus 4, which is less than 0. So therefore, there are, whenever we get b square minus 4ac less than 0, so since root under negative is not possible, so we say that there are no real roots for the given equation. Okay. The next question. Find the roots of the following equations. Number 1, x plus 1 by x equals to 3, x naught equals to 0. So solution, we have x square plus 1 by x equals to 3, which implies x square plus 1 equals to 3x, which implies x square minus 3x plus 1 equals to 0. So now in this case, see, 1 into 1, a into c is 1. So if you have to divide 3 into 2 parts, say 2 plus 1, 2 plus 1, 2 into 1, we will get 2 only. So there is no, this middle term breaking over in this case is not possible only. So what we do in this case is we have to use the quadratic formula. So this is of the form ax square plus bx plus c equals to 0, where a is 1, b is minus 3, c is 1. So using quadratic formula, x will be equals to minus b plus minus root under of b square minus 4ac divided by 2a. So this is equals to 3 plus minus root under of 9 minus 4 by 2. So this is 3 plus minus root under 5 by 2. So what we get is, this implies x equals to, once we'll take 5, so 3 plus root 5 by 2, and the other will take the minus sign, so x equals to 3 minus root 5 by 2. So this will be the two solutions of the quadratic equation. The second question, 1 by x minus 1 by x minus 2 equals to 3. So this implies we have x into x minus 2 minus x equals to 3. So here x minus x cancels off, so we have minus 2 equals to 3x into x minus 2, cross multiplying them. This implies minus 2 equals to 3x square minus 6x, which implies 3x square minus 6x plus 2 equals to 0. Minus 2 goes to the side, plus 2, and we wrote a 0 just on the right hand side. So this is of the form ax square plus bx plus c equals to 0, where a is 3, b is minus 6, c is 2, using quadratic formula, x will be equals to minus b plus minus root under of b square minus 4ac by 2a, which is equals to 6 plus minus root under of 36 minus 4 3s are 12, 12 to 24 by 6, which implies 6 plus minus root under of 36 minus 24 is 12 by 6, which is equals to 6 plus minus 12 is 4 into 3. So 4 root under 4 is 2. So root 3 is only left by 6. 2 comes common. 6 plus minus, 3 plus minus root 3 by 6. 2 1s are 2 3s are 6. We have 3 plus minus root 3 by 3. So the roots are, once we will take plus 3 plus root 3 by 3, and in one situation we will consider minus 3 minus root 3 by 3. And in some questions you may also be asked to find the your value up to 2 suitable figures. So that means up to 2 decimal places, and you need to remember to replace value of root 2 as 1.414 and value of root 3 as 1.732 if it's asked in the question. If not, then you can leave it in this way itself. If you are asked to find 2 decimal places, replace root 2 and root 3 as these values and you solve them, and then you round it off at the end. Okay, last question for today. Find the roots of the equation x square plus x minus a plus 2 into a plus 1 equals to 0. So solution. So we'll start using quadratic formula. So using quadratic formula, x equals to minus b, that is the quotient of x, plus minus root under of b square minus 4 into a is 1 into c. This whole part, the constant term is c, that is minus of a plus 2 into a plus 1 whole divided by 2 into a, which is equals to minus 1 plus minus root under of 1 minus into minus becomes plus 4 into, expanding this we get a square plus 3a plus 2 whole divided by 2, which is equals to minus 1 plus minus root under of, so 4a square plus 4 3s are 12a plus 4 2s are 8 plus 1 9 by 2. So this is equals to minus 1 plus minus root under of, if you look at this closely, so this is 2a whole square plus 2 into 2a, so this becomes 4a, here we have 12a, so 4a into 3, and we have 9, so we can write that as 3 square by 2. So 4a square, we wrote it as 2a whole square plus 2 into 2a into 3 plus 3 square. So this is equals to minus 1 plus minus root under of 2a plus 3 whole square by 2. So that is minus 1 plus minus root under, and this square cancel off, we have 2a plus 3 by 2. So which implies x equals to minus 1 plus 2a plus 3 by 2, or x equals to minus 1 minus 2a minus 3 by 2, which is equals to 3 minus 1 is 2a, 2a plus 2 by 2, or x equals to minus 2a, minus 3 minus 1 is minus minus plus, so plus 3 minus 1 is plus 2 by 2, which implies x equals to a plus 1, 2 comes common and cancels off, or x equals to, over here we have 1 minus a. So this will be the value of x. We made just one mistake over here. This was 2a plus 3. I wrote this as minus. So minus into plus 3 is minus 3. Minus 1 minus 3 will over here be minus 4. So 2 comes common. Minus 2 comes common. We'll have a plus 2 by 2. 2 cancels off. So x equals to minus of a plus 2. So either it's a plus 1 or it is minus of a plus 2. So therefore the roots are either a plus 1 comma minus of a plus 2. So with this we conclude today's lecture. Thank you.